Hi, this is Dr. Chen, the instructor of your business calculus class. Today we are going to study section 1.1. Let's start. Since calculus studies the behavior of functions, we start with functions and graphs. So what is a function and how do we evaluate it? The learning goals for this section include 1. Understand the definition of functions, its domain, and range. 2. Be able to evaluate the function by its graph. And 3. Be able to evaluate a function by its formula. So let's start with a brief story. Okay, we have a driver realized that he needs to add gas to his car, so he pulls into a gas station and noticed that the price of a gallon of gas is $3.90. So how much does it cost him to purchase gas? And you realize, yes, it depends on the quantity he purchases. So assume his car can hold at most 20 gallons of gas. So now we have a relation between cost and the amount of gas he purchases. So we have 4 ways to represent this relation. The first is just to use words. It said the cost of purchasing X gallons of gas is the price of $3.90 per gallon and multiplied by X gallons. And it seems like tedious. And we can also use a numerical table and which listed a few of the values. Now the more obvious way is to use a graph. Okay, and notice that I do want to indicate on this graph, okay, the x values were from 0 to 20, and this line, that's actually a segment from 0 to x equal 20. Okay, it stopped there. Why is that? Because his tank can only hold 20 gallons. And so similarly, the cost is, how do we find the cost? And that's by multiplying $3.90 to x. So the graph gives a obvious relationship. We see that it's a line going up. However, if we want to calculate, like if I purchased 15 gallons of gas, how much should I pay? Its most convenient way is to use a formula. Okay, use a formula. And actually in calculus, we use this expression. Usually we study the formulas of a function. And occasionally we do use a graph because graphs are so visual. Okay, so in order to write a formula, we put some notations, and we say the x is the input, okay, or the independent variable, and we say the responding variable is the dependent variable or output. Okay. And what is a domain? A domain means all the x values that makes a response meaningful. And the range is all the responses. You know that many relations can be classified as functions. There's only one restriction, and that is for each input, a function only give out at most one output. So for example, in daily life, okay, everyone had one biological mother. So your biological mother Okay, so a person's biological mother, that relationship is a function. Okay, given any person's name, you can find his or her biological mother. Conversely, okay, reversely, if we're talking about the child of a woman, and then that woman may have more than one child. And therefore, the child of a woman is not a function relationship because give Mary, okay, you ask who's Mary's child? And say, hey, Mary has a daughter and a son. So she has 2 children. So that's not a function. And that's important to be reflected into the graph. So the first example is just a discrete example. It's easy to understand. And the second example, we have a formula. We talk about domains. And for us, the only thing we need to remember is a domain of a function given a formula. There's only few restrictions. Okay, the first restriction is the denominator cannot be 0, and the second, inside a even root, the function value cannot be negative, and the third, for a logarithmic function, and then inside the log, you cannot take 0 or negative values. And we will see. Okay. Now, we focus on how to evaluate functions. Okay, so the details in example 3 is illustrated in the other file. So here I just go briefly summarize the steps. If we are given a formula which says f of x is 2 times x squared minus 3x, if we want to evaluate f of 2, we replace x in each location by value 2. Okay. If we're evaluating f of 5a, so we replace x by 5a. And for f of x plus h, so you say, hey, it looks like, here gives x, right? Why we're given x plus h? It doesn't matter. Okay, so whatever occurred inside f, we use it to replace x in the original formula. So we have f of x plus h is now x squared becomes x plus h squared, and x become x plus h in the second term. And the remaining are algebraic works. And similar steps for third root of t, and we replace. If you're comfortable evaluating these formulas, you may not need the details. But otherwise, in the PDF file and also the video file, okay, you can find the details of evaluating functions either on graph or for a formula. Example 4, okay, we give a formula as 2x minus 5x squared, and now we want to evaluate this quotient, and which is called a difference quotient, and that is very important later because we're going to use this formula to define the derivatives. Okay, so in order to evaluate this quotient, we do step by step. The very first formula we plug in is f of x plus h, and that's why we evaluate f of x plus h separately and do some simplification, extend all the parentheses and the powers, so we get this formula to replace f of x plus h, and we simply copy the formula of f of x for the second term, and don't forget the parentheses. Okay, and careful algebra work will get cancelled of all the terms which do not involve h. So the remaining term will have h as a common factor. We factored out, and that get canceled with the denominator since h is not 0. So that will be the answer for the simplified difference quotient. So now let's turn into the graphs. Okay. First, we briefly talk about how to make graphs. Okay. So for each function given a x value, it had either no response or there's a y value to response. So we can form a pair. And if we mark this pair into a point in the x and the y coordinate system, say 5 and 25, here's a 5, it's x value, and 25, it's y value. So we dot these points here, okay, point here. So similar way we can do curves, but of course it's harder to exhaust all the points. So what we do is to sample a few points and mark them in the coordinate system, and then link these points. Now don't worry about the graphing of more complicated functions, because one of the topic of calculus is to study how do we do the graph. So here is the feature to judge whether a given graph represent a function or not, and this is called a vertical line test. So if you hold a vertical line and wipe it through the whole graph, if anywhere the vertical line hit the curve more than once, and then this is not the graph of a function. Okay, so that's the vertical test. So finally, it's the evaluating a function by a graph, by its graph. Now example 7. Okay, I just want to indicate how we do this problem, and it's fairly easy, but sometimes our eyes kind of like want to trick us. And in particular, let's look at this g of 1. Okay, g of 1. So if we look at around g, here's the graph. We'll say, hey, here is going to -1, -1. So should this one be -1? No. Function evaluation on graph is kind of similar to a sky jumper. So you got someone jump from sky at this location 1 and shoot down straightly. In other words, you are holding a vertical line, and where the vertical line hit the function curve, and including this dot. Okay, so if it hit the dot, then the vertical value of this dot, 3, is function value, g of 1. Okay, it's g of 1. So you may ask, now what if this dot is removed? It's not there. And that's worked too, because in that case, the vertical line will go through without hitting the curve. Now, if the curve didn't get hit, which means the function has no value at this particular location. So our answer for g of 1, if the dot is removed, would have been D and E, which means does not exist. Okay, the other values are easier to hit. Say that if we want to evaluate g of -2, so where is -2? It's here. So the vertical line will go through this curve and hit this point. And at this point, the vertical reading is 2. So g of -2 is 2. And for g of -1, if we hold a vertical line, it goes through this location. And where does the vertical line hit the curve? At this black dot. So the vertical reading of this black dot is 1. Therefore, g of -1 is 1. That concludes the section 1.1, Functions and Graphs. So now please take the daily quiz and compare with the answer.